Raj Academy. In this lecture, I am going to teach you about the ISRO 2013 question paper in a very detailed manner. See, the first question says that the characteristic impedance of a quarter wave transformer connected in between a load of 100 ohm and a transmission line of characteristic impedance of 225 ohms. So now they have given the load impedance and the transmission line impedance. Then we need to find what is the characteristic impedance. So the options are 100 ohm, 225 ohm, 600 ohm and 150 ohm. So the formula is the characteristic impedance ZC is equal to under root over ZL into ZL, where ZL is the load impedance which is 100 ohm and the transmission line impedance is 225 ohm. So if you substitute this 100 ohm and 225 ohms in this equation, then you will get under root over 100 into 225. If you do this simplification, we will get 150 ohm. So therefore finally the characteristic impedance is equal to 150 ohm. So the option D is the correct answer. The Kirchhoff laws fails in the case of. So here the question is the Kirchhoff laws fails in the case of. The options are nonlinear networks, linear networks and dual networks and distributed parameter networks. See here, whenever the frequency is low, means whenever the frequency is low, we are going to deal this all the circuits in electric circuits, means in network theory. All the circuits in the network theory are below frequency, means the frequency are very low. So therefore all the components can be easily lumped. Means any resistor, any inductor or any capacitor, we can easily give the representation for them. So therefore we can easily lump them and we can draw the diagrams and we can solve the unknown parameters. But when the frequency is high, means whenever the frequency is very huge, then we are going to deal all those circuits by field theory. Means in the field theory always we will get the most accurate results, but in the electric circuits always the results are very approximate. So in the high frequency zone we cannot lump the parameters, the resistor, inductor and the capacitance. So therefore these are called as the distributed parameters. So in the lumped network, the KVL and the KCL are going to satisfy, because we can easily expressions for the lump circuits, and in those equations we can find the KVL and the KCL. But when in case of distributed networks, we cannot represent any parameter lumped manner. So therefore in this distributed parameter network we cannot write the KVL and the KCL. So therefore we can conclude that KVL and KCL are not satisfied. We cannot apply in distributed parameter network. So therefore among these four options, the correct option is the option D, which is distributed parameter networks. Third question of this lecture series. See, the question is which of the following measures cannot be effective in reducing the noise? Means by some method, if we want to reduce the noise, what is the ineffective method? Means out of these four options, the option is which is going to increase the noise. It is telling you in the indirect way. Means this method is not going to affect in reducing the noise. Means by this procedure we can easily get the more noise. See, the basic formula is in any amplifiers, the rise time into the bandwidth is always equal to the constant value. The constant value is 0.35. Here the rise time has the units of seconds and the bandwidth has the units of hertz. So therefore always the bandwidth is directly proportional to the noise. Means whenever the bandwidth is more, then there is a chance of more noise can add to the original signal. So therefore the original signal can get more amount of distortion. So therefore always it is preferred to have a less bandwidth. So therefore the noise which is going to introduce in this range can be minimized. So therefore if we increase the channel bandwidth, there is a more possibility of noise is going to there is a more possibility of the noise in the given range. So therefore the original signal may get distortion. So therefore by increasing the channel width, there is a less effective of reducing the noise. So therefore, but the remaining three options are going to reduce the noise, means by reduction in signaling rate and increasing transmitted power and the use of redundancy. These three options are going to reduce the noise, but the increase in channel bandwidth is going to ineffective in reduce the noise. Is the energy stored in the magnetic field in a solenoid of length 30 cm and diameter is 3 cm, wound with 1000 tons of wire and carrying a current of 10 amperes. So they have given the length of this solenoid and also the diameter is 3 cm and it is wound with 1000 tons of wire and the current is 10 ampere. So now we need to find what is the value of the energy which is stored in this magnetic field. See, the basic formula energy is half L I square, half into L into I square. So first we need to figure out what are the values which are given in the question. See, they have given the length is equal to 30 centimeters. So we are going to convert all this into the SI quantities which are the meters, means 0.3 meters. And the diameter of this core of the solenoid is 3 centimeters. So therefore in terms of meters, which is 0.03 meter. And the number of turns is 1000 turns and the current is 10 ampere. So we need to find what is the energy stored in the magnetic field. So therefore E is equal to half L I square. So we know the I term. I is already given in the question, which is 10 ampere, but we need to find what is the L value. Then we can easily find our required parameter to find, which is E. So therefore first we need to find the value of the L, then we need to find what is the value of the E. See, L is equal to N square by R. N is the number of turns and R is the reluctance of this core. See, the basic formula, the reluctance R is equal to L by mu A. So if I rearrange these ones, we will get mu into N square A by L. Here the reluctance formula is R is equal to L by mu A. So if you substitute in this equation, then we will get this one, which is mu into N square A by L, where mu is the permeability of the core. So mu is equal to mu naught into mu R, but here mu naught is equal to 4 pi into 10 to the power of minus 7. See, here mu R is equal to 1. We are assuming it 1 because we are assuming it is a air present there. So here actually in the question they have not given anything about the mu R. So by default, if nothing is given in the question about the mu R, then we need to assume it as mu R is equal to 1. So therefore mu is equal to mu naught into mu R. So mu R is equal to 1 means mu is equal to mu naught, which is 4 pi 10 to the power of minus 7. See, now we need to find what is the area of this solenoid. A is equal to pi r square, but r is equal to d by 2, means we will get pi by 4 d square, where d is the diameter of the core. So if you substitute all these values in this, we will get finally L is equal to 2.96 millihenry. So now we know the value of the I, then, and we also know the value of the L. So finally we will get what is the energy in this field. Here E is equal to, if you substitute all those values, we will get E is equal to 0.15 joules. So therefore the required solution is answer B. Here 0.15 joules. Putting in parallel, we share the load depending upon there. The options are ratings, leakage reactance, efficiency and per unit impedance. See, the option is per unit impedance, which is option D1. See here, this is from secondary side. There are two transformers. These are the secondary side of the transformers, and these are the per unit impedances, and these are connected in the parallel fashion across the load. Here the load rating, the load impedance is ZL, and the load is consuming a power of kVA rating of SL. So now we need to find what is the kVA transfer or kVA shared by this transformer T1 and the kVA transferred by the shared by the transformer T2 to the load. Here the kVA which is shared by the transformer 1 is equal to Z2 by Z1 plus Z2 whole conjugate into SL. Here Z2 is the per unit impedance of the secondary transformer by the total summation whole conjugate into SL. And similarly for the kVA which is shared by the transformer T2 is equal to Z1 by Z1 plus Z2 whole conjugate into SL. So now we can easily conclude that here the kVA which is shared by individual transformers is depending upon the per unit impedances. So therefore the correct therefore the correct answer is the option D. Here the kVA which is shared by the transformers to the load is depending only purely on the per unit impedances. As the transfer function of system described for the system. See, the options are only zero input response, only zero state response, both zero input and zero state response, neither zero input nor zero state response. See, here we can find the transfer function of any LTI system in the both ways. The both ways are, first, the transfer function is C of S by R of S. That is a standard procedure we can find out. Or in another fashion is, first we need to find what is a zero state response and then zero input response. See, zero state response means all the state variables are assumed to be zero in this case. So here all the state variables are assumed zero. So therefore the response is because of only the input. So that is the reason it is called as a zero state response. But here it is called zero input response, means here the input is made zero but the state variables are non-zero in this case. So therefore the output in this case is only because of the state variables, but the inputs are zero. So therefore the response is called as a zero input response. If you do this both and if you do addition, then we will get the transfer function finally. Here zero state response and zero input response. In these both manners we can find the transfer function of any LTI system. The question is, the discrete time system discrete by y of n is equal to x of n square is. So now we need to find whether this system is a linear system or whether it is a causal system or whether it is a time varying or time invariant system. So first property is linearity property. We will check whether this system is a linear system or a non-linear system. See here, suppose for this LTI system, suppose for this system we have given x1 of n as an input. So therefore the output y1 of n is equal to x1 of n square. But if you give x2 of n, we will get y2 of n is equal to x2 of n square. Suppose I am giving x3 of n, which is a summation of the previous two inputs, which is x1 of n plus x2 of n. So therefore y3 of n is equal to, we will get x3 of n whole square, right? Here x3 of n whole square, I didn't write here, see here, which is equal to x3 of n square, right? But here x3 of n square means we can write here x3 of n square means we can write here x1 of n square plus x2 of n square. So here, but x1 of n square is also equal to y1 of n, and here x2 of n square is also equal to y2 of n. So therefore y3 of n is equal to y1 of n plus y2 of n. Means when we give x3 of n is the summation of the previous two inputs, here the output is also equal to the summation of the two previous outputs. So therefore when this property is satisfied, then we call it as a linear system. Means I am repeating it again. So whenever the new input is the summation of the previous two inputs and the output which we got is also summation of the two previous outputs, then we can blindly say that this system is a linearity system. Now we will check whether the system is a causal system or a non-causal system. See, now we are going to check the another two properties. See, the other properties, whether the system is a causal system or a non-causal system. See here, I am taking at instant t is equal to 2 seconds. The output at instant t is equal to 2 seconds. Here x of 2 square means 4. Means at t instant t is equal to 2 seconds, the output depends upon the input, which is depends upon 4 seconds. Means the present input is depending upon the future input. So therefore this system is called a non-causal system. See, causal system means if any output depends upon the present input or past input, then we call it as a causal system. Or otherwise, if the output depends upon any future input, then we call that system as a non-causal system. Here the present output depends upon the future input, so it is called as a non-causal system. So we have concluded the system is a linear system and a non-causal system. And the third thing, we need to find whether the system is a time variant system or time invariant system. See here, let me assume the input which is x1 of n. So therefore the output of the system is y1 of n is equal to, here let me assume x1, here y1 of n is equal to x1 of n square. Let me assume x1 of n is equal to delay of the original signal, which is x of n minus n0. So therefore here x1 of n square means in place of n we can blindly write it as a n square, because x1 of n square is equal to x of n square minus n0. So here also x of n square minus n0. This is the actual output which we got for this delay input. See, for x of n minus n0 we got output which is x of n square minus n0. See, now we need to find what is the y of n minus n naught. Y of n minus n naught. Here we got here x of n square minus n naught. These two outputs are same. So we can conclude that here this system is a time invariant system. See, whenever these are equal, then only we call it as a time invariant system. Suppose if these both are not equal, then we call it as a time varying system. See, so output is equal to y1 of n. Let me assume x1 of n is equal to some delayed version, which is x of n minus n naught. So therefore here also x1 of n square means in place of n we need to write n square. Similarly here y of n minus n naught. We know y of n is equal to x of n square, but y of n minus n naught is equal to x of n square minus n naught. So therefore these both are equal. So blindly we can say it as a time invariant system. So if you see the options here, the first option is causal, linear and time varying. No, it's not the case. Causal, non-linear. No, non-causal, linear and time invariant. So the correct option is answer C. This is the correct option. So the system is a linear system and non-causal and time invariant system. Now next question is, a network is said to be linear if and only if. See here, this is a linear network. Linear network means, suppose if I have given an input x1, let me assume the output is y1. Suppose if I have given an unknown input which is x2, I got the output y2. Suppose if I add this previous inputs, which is the new input is the summation of the two previous inputs. So therefore the new output has to be equal to the summation of the two previous outputs. Then if this is possible, if this is happens, then only we can say the system is a linear system. Suppose if it is not happen in this way, then we can say blind it is a non-linear system. Suppose what I did is, I did a scale factor, multiplied a1 to the previous input which is x1. Means I have multiplied a constant variable which is a1 to the previous input. I got a scaled version, same scaling factor of the output. Suppose if I did a2 multiplication, then I got the same previous output with the scaled version of a2. Suppose if I add these two inputs, previous inputs, then the output has to be equal to the summation of these two previous outputs. Then if this happens, then we can blindly say this as a linear system. This is called as a then only the system is said to be linear system, means superposition and the homogeneity, and this scale is called as a homogeneity and this is called as a superposition. So if we both combine this, both superposition and the homogeneity, these two applied in this case, that is why this is called as the linear system. Means superposition and the homogeneity, these two properties are satisfied, this equation is satisfied. So therefore this system is said to be a linear system. See here, suppose if I am assume this a1 is equal to 0. Suppose if I assume a1 is equal to 0, here also the output has to be equal to 0. So therefore what I am trying to say is, in a linear system if the input is 0 and then blindly the output has to be equal to 0. If that is not the case, then we can blindly say that system is a non-linear system. See here example, let me tell you some small example. Here some of the system, suppose let assume a system which is given the relation between the output and input is just 2x plus 3. Suppose this is a linear equation, but it is not a linear system, because see this is a in mathematics we can draw this as some straight line, so we call it as a linear equation. But in terms of this system's property here, suppose let me assume x is equal to 0. Suppose input is equal to 0, here 2 into 0 plus 3, but output is not equal to 0, it is equal to 3. Means whenever the input is 0, the output has to be 0, then only we call it as a linear system. But if it is not the case, if input is 0 and if output is not equal to 0, then we can blindly say this system is a non-linear system. Means if any system which has an input is equal to 0, then the output has to be equal to 0. Then only the system is called as a linear system. If it is not that case, then we can blindly say it is a non-linear system. So therefore the option is, the principles of superposition and homogeneity apply, then only the system is said to be a linear system. Question is here, the transformer core is laminated. Why the transformer core is laminated? See, to avoid eddy current and hysteresis losses. See here, in this, the transformer, always the cores of the transformer are laminated into different small sheets, and here we will keep some varnish painting so that the insulation will be very much high. So therefore here there will be huge amount of resistance because there is a small air gap is there. So therefore the current, the eddy currents can't flow from this sheet to the other sheet. So from this lamination to the another lamination. So the eddy currents will flow on this small lamination itself. So therefore the losses will be very less. See here, P is equal to eddy current loss is equal to K into Bm square F square T square into volume of the core, and hysteresis loss is equal to KH into Bm to the 1.6 F into volume. Here see, T means the thickness of the lamination. So if the thickness of the lamination decreases, then eddy current loss is also decreases. Here, if you use the different if suppose in this case we are using laminations, right? By using laminations, the volume of the core is reduced. See, whenever the volume of the core is reduced, here hysteresis loss is also reduced. So indirectly, what we are telling is, whenever the transformer is laminated, here the eddy current loss is reduced and also the hysteresis loss is reduced, because here hysteresis loss is reduced because of the volume is decreased. But in case of eddy current loss, the eddy current loss is decreased because we are using thin lamination. So the eddy current is within the lamination itself. So it can't pass from one lamination to another lamination. So there is a reduction in the eddy current losses. Whenever the thickness is decreases, the eddy current losses also decreases. So the right option is to avoid eddy current loss and hysteresis losses, the transformer core is laminated. Of this lecture, the question says that in a 4-branch parallel circuit, 50 milliampere current flows in each branch. If one of the branch opens, the current in other branches. See here, this is the case 1. See, each resistor is R, and this resistor, the current is flowing in each of this resistor is I amount of current. The value of the I is 50 milliampere. So therefore the net inward current is the input current which is going through is 4I, because I plus I plus I plus I by KCL, the input current through this junction is 4I. See, all these resistors are connected in parallel. So therefore, as the currents are equal, so therefore the voltage, as they are connected in parallel, the voltage is across each and every resistor is constant. So therefore the current is equal to voltage by resistor. As the current and the voltage are equal, the resistance of each and every resistance is also equal. See here, suppose if one of the branches I have removed from here, suppose this branch I removed, so therefore I open this one, the remaining 3 branches resistance are equal and the voltage is also same. See, the same I is equal to V by R, as the voltage is same and the resistance is also same. So finally the current in each branch is also same as the previous one, which is 50 milliampere, but the input current which is 3 times I, because I and another current is open circuit. This branch is open, so current in this branch is equal to 0. So input current is equal to 3I. So each and every branch current flows is same as the previous one, which is I. So therefore which is unaffected. Even if you remove the another branch, or if you remove any of the 3 resistors also, finally the current in that branch is always same as the previous case. 10 previous year questions which are the ISRO 2013 questions. If you like the content of our channel, then please do like, share and subscribe our YouTube channel, and don't forget to press the bell icon button. So whenever we upload a new video, the direct notifications comes to your mobile. Thank you for watching this lecture. Keep smiling, take care and bye bye.